Welcome back. This is video 2 of 3 for the Pioneer SX-990. In this video I will be working on the front faceplate and the power supply board. Enjoy! Electronics can be deadly. My videos are for entertainment purposes only. If you attempt anything you see in my videos, you are doing so at your own risk. Okay, I took a little break from replacing capacitors and I thought, you know what, I'm just going to throw the new LED lamps in here. So these are the 4 little LED lamps, and then I also have other lamps that are going to go across the top. If you need lamps, check out Joseph Mirabella, Joe's Quality Wholesale Lamps.
Feel you gleam, and with our
There you have it.
delivery, you won't have to leave the AC.
So let me turn some of this light off.
We'll even bring over some gourmet snacks because it's summertime and Specs has
Just move this out of the way.
Specs wine, spirits, and finer foods. Cheers to savings.
So that's not exactly what it's going to look like.
At Siemens, we've been building the backbone of America's economy for over 160 years. So we don't.
I'm going to shove this in here.
Only as strong as the people behind it. Our 2,000 Dallas-Fort Worth employees are ushering in the next American
not bad.
manufacturing revolution. Building
Turn this light off.
data centers, battery plants, and more. And we're growing fast. Looking for all backgrounds and skill sets to help build.
If I can turn the knob.
Today, visit usa.siemens.com/txt.
There we go.
usa.sie.com/com.
Now I have lamps. New lamps for these over here. I'll have to decide whether I'm going to put those in. They kind of look nice the way they are. They're working just fine. I might put them in just to see how the LEDs look. I don't know, but they look good. And the dial pointer light is already working, so I'm not sure I'm going to switch that out either. Okay, there are 2 different types of LEDs or lamps that go in here, and the ones that go in these are the, what are they called? Bayonet. They're bayonet LEDs, and they look like this because they screw in and then they snap in and lock. And then the other kinds that go into the meters are screw-in types. So you can see the difference. One's a bayonet, one's a screw-in. So I'm going to go ahead and put in all the bayonet ones. Try not to mess with the dowel string. One more down here on this end, and then let's just turn it on and Just make sure everything is looking good. Okay, so we are currently in stereo FM, so I'm assuming that's where that would be. If I go one notch to the left to the mono FM, it stays lit, which I guess is okay. The next one to the left should be, or to the dial counterclockwise is AM. You can't see it, but this one right here is lit up. And then let's go back. There's FM mono, FM stereo, and then we have phono, phono mic, and aux. So the next one over is phono. That's phono 1. And then the next one to the right or clockwise should be phono/microphone. And the final one is auxiliary. Awesome. Looks good. And you can see that the stereo, well, maybe you can't see that. Let me just show it to you. Okay, so this is AM. Right there. There's AM. And then one notch clockwise is FM mono. And then one more to the right is FM stereo. Nice. Good deal.
Before we get into the actual work of the power supply board, I wanted to just go over, how I keep track of the work I'm working on. And I like to use Excel for the replacement of the parts to keep track of what I'm going to replace, what they measured at, all this information here. I also like to put a screenshot of the board on the actual spreadsheet, the worksheet that of the board. So if we look here, W15060, that's the main amplifier board. So I create a different tab or sheet for each board that I work on, and then that way I can switch to one tab. For example, this one's the power supply, and I can see everything I need to see related to the power supply on this spreadsheet. And I get a complete list from the service manual as well as the board layout. And when I'm in here looking at C1, I can go, oh yeah, I know where C1 is. It's right over here. So here are the things that I like to keep track of, what the original specifications are for each one of them, what their measured value is, what I want the target value to be at, and then whether I'm going to replace them or not, and what the replacement specifications are. Now the colors, codings mean something to me. I've already replaced these, so I've highlighted them in green to indicate that those are finished, right? And gray is not going to be replaced. And if we go over look at the replacement notes, I indicate the replacement part with a link to the actual part that I replaced them with, and any notes related to this work at all.
Continuing on the bottom, well, I ended up finishing the front, so all the switches and knobs and doodads are all clean and lubed, and they're all good to go. So the next thing I want to focus on is power. And before I target this board here, which I'm assuming is probably going to be recapped because, original, I'm going to test the power that's coming out of the transformer to make sure we're getting the correct voltages out of the transformer. I'm going to put that on a variac, and instead of putting 120 through it, I'll put like 10 through it, and then I'll check the voltages. It's much safer that way, and then you can do the math and extrapolate what it's actually going to put out later. So we'll do that now, and we'll see what we get.
So what we have here is the main, power plug that you put into mains, and that comes in yellow. My apologies if you can't see that. It's if you're colorblind, it's this portion over here on the right that shows the plug that comes around to this main portion of the transformer. So this primary part of the transformer right here is labeled white and gray. Now I measured the voltage. I set a input voltage and measured it exactly at 120 volts, and then between white and gray I ended up getting 120 out, exactly on white and gray. And then the transformer has 3 secondaries. It has the bottom one, which is here, is labeled red, the middle one's labeled green, and the top one is labeled blue, and that one's primarily used for the lights and indicator units. So the measured values for the secondary on the red here were 105 volts. And the schematic list that it expects 117, so I extrapolated, so it should be around 102. It's not listed anywhere what it should be, but this is what was measured. And on the secondary over here on the right, the resistance, the DC resistance between the two red points across the secondary is 1.33 ohms. It was 3.52 ohms across the green secondary and 0.22 ohms across the blue secondary. So the measured voltages at on the green secondary was 34 volts, calculated was 33.35, and on the blue it was 8.33, and the calculated, if it was 117, it would be 8.12. Now the expected, if you can see it at the top, it's hard to see, but you can see here it says 7.5 volts here. So we're not far off, so I'm considering this transformer to be good and in good working condition, so we can move on to the rectification portion of the power supply. So since I have it on the screen right here, you can see there are listed 5 outputs, and you can see B1, 2, 3, 4, 5, 56 volts, 40 volts, 25 volts, 18, and 12 respectively. So now we're going to go back over to the receiver and measure those values.
Okay, so what I'm going to do now is I'm just going to show you that I'm going to set the input voltage down to 117 volts as well as I can. And there you have it. So we have 117 volts AC coming in, right? So we now have calibrated the input according to what the manual and specifications say it wants. So now we're switching over to DC voltage, and we're going to measure the rectified output. There are 5 expected outputs. We have B1, 2, 3, 4, 5. Expected B1 value here we have 68.62 coming out. That value is supposed to be 56, so it's a little high, but it's okay. 2 is 39.73, and the expected output on that one is 40, so that one is spot on. The expected output on B3 is 25 volts, and that's right here, and 27.76. Not bad. B4 is supposed to be 18. And we're getting 21.6. And B5 is supposed to be 12, I believe. 12, we're getting 12.38, which is great. Now, take into account that nothing in here has been tested. All the caps are original. And I haven't checked values for anything at this point. So now I'm just going to pull the board out and check some capacitors. I mean, realistically, I'm going to replace these because this is going to be a gift for a relative of mine. And so I don't want it coming back. I want it to sound great and good as possible and be as reliable as possible so I don't ever have to look at it again. So let's pull that board and take a look at some of those capacitors and resistors. One other thing to mention before we start messing with the power supply board, as I just mentioned, is that the main filter cap right back there is large. And one thing you should do after turning it off before you start messing with anything inside the unit is to discharge that capacitor. So I haven't done that yet. I just wanted to show you that if we switch the meter to DC, which we have, and we just kind of hold it up here. If I put my terminal on the other part of the capacitor, yeah, you can see it's dropping, but it was at like 37, 38 volts when I originally looked at it, but you see it's dropping now. But you definitely want to deplete this capacitor or discharge this capacitor before start working on anything. Otherwise, it could hurt you or kill you. So be warned. Well, it looks like it's it. That's all for the electrolytics. They all look great. They all look fine. You know what? Let's just pull one and verify that, because this only does ESR. So come on, little buddy. You can do it. There you go. Okay. Okay, I pulled that cap out, and as you can see, it's measuring a little high. It's supposed to be 100 microfarads, and it's almost 30% high, so that's not good, and that's at 100 hertz. The first two capacitors we are going to replace are C1 and C2. This is rated for 100 microfarads at 50 volts and 100 microfarads at 25 volts, I think. I can't remember exactly, but both of these are going to get 100 microfarads at 63 volts. And they're these two here. These are the Nishikon UPWs. So if you look at that, that's what we're going with. Okay, those two are in. The next three are 4, 5, and 6. These are all 220 microfarads. Specifications call for a 25, a 25, and a 10. All three of these are getting replaced with a 63 volt. Turns out that C3 here in the middle is also a 220, so it's going to get the same Nishikon 220 capacitor that was for 4, 5, and 6. Okay, just verifying ground polarity. Okay, so the only other component that I believe we need to replace on this power supply board is this transistor here. And this transistor was a 2SC905, and we are going to replace it with a KSD 1616. And just to verify what we're looking at here, the gain on this is 314. Pinout is slightly different, so we'll just need to be careful of that when we replace it. Okay, so this board has been repopulated, but it is severely dirty in my opinion, so I'm going to reflow some of these joints, and then I'm going to clean the bottom of the board and just get looking better. Okay, power supply board has been repopulated, cleaned, and is looking much better. So now we'll kind of put everything back together, and we'll replace that main filter cap. Okay, before I put everything back together, I just wanted to go and hook up the main filter cap. The new filter cap is 3300 microfarads, and it replaces this 2200 microfarad, and you can see that they're basically identically the same size, and that was one reason I picked that filter cap. It's got great specs, and it's a higher voltage and higher capacity. So we have 118 volts main coming in right now, 118.8. And so here's B plus. We're going to show you B plus 1, 2, 3, 4, and 5. And let me see if I can do this without putting my hand in the way. Try. So there's B plus 1, which is right at 70. 2 is at 39. 3 is at 27. 4 is at 12. I think that's 5. 5 is 12, and 4 is right at 22. Everything's looking good. So I'm going to go ahead and install the filter cap, and then put the main amp board back in, and then we'll fire this puppy up and see where we need to go from there.
This abruptly concludes video 2, but please come back next time for the final video where I will work on the remaining boards, as well as cleaning, waxing, and polishing the case exterior. Thank you for watching, and I hope you have a blessed day.